Okay, sixth grade, our objective today is to talk about solving equations. We are going to specifically today talk about solving a one-step equation. At this point in this class, we've done expressions, we've done combining like terms, we've done order of operations. We're going to talk about solving equations. It's extremely important that you understand the steps of how to do this. I'm going to go through those today. We're going to do a bunch of examples. I am going to combine lessons 2-4 and 2-5. Because lesson 2-4 is way too easy for you guys to spend one class period on. So we're going to mush two of them together. The next time you'll have a test in this chapter will be when we're done with the chapter. Okay, so the next time you'll see a test is the chapter 2 test. Your quizzes from yesterday are not completely done. I apologize. I was finishing up the 9th and 10th grade algebra tests. So those are all done in the grade book. Yours are almost done. By the end of the school day today, they should be in the grade book. So if you want to check when you get home, the score should be in there. They were out of 40 points. They look good so far. So check. If you have any questions over the weekend, feel free to email me. Annalise? I know, because whenever I post it, I always just pick up points, an amount of points to put it out of, because I'm never sure until I make an answer key. Once I make the answer key and grade them, then I know how many points it is. So once I enter the scores, Annalise, I'll change it to 40. That's something I just do because I like you guys to see what's coming up as well as parents. Charles? When I grade test, I grade one page at a time, so I'm consistent and fair. So like if I take off half a point on one of your problems because you forgot a negative, I like to do that for all of them. You know what I mean? So I grade one page at a time, not one test at a time. Correct. The tests are in progress, they're just not done. Okay. Well, I did finish part of them, but not an entire test. All right, so let's go over our warm-up and get into our problems today. Okay, so I basically had you guys and girls do most of page 11 in your notes. So we're going to go around the room and let's see how you did on this. Justin, what'd you get for 1A? Good. Donatus, 1B. Good. You may also write it as 14 over Y. Doug, letter C. Good. How else could we write this? Emma H. Good. 7 with a little dot times Q. Make sure it doesn't look like a decimal point, so be careful with that. Charles? Did you not read the directions? Oh, that's okay. That's okay. Did you have, what's the third way we could write this to mean multiplication? Good. You could also write it as 7Q. Any three of those is acceptable. Briar, what did you get for 2A? Good. Sean, 2B. Good. Adam, 2C. Good. 3, Zach, what are the like terms? What kind of 5 in? Good job. Annalise, the coefficients. Good. Jeremy, the constants, or constant. Okay. Alyssa, the terms. Good job. Okay, let's go to the simplify expression, but just let me move this real quick. Okay, Doug, what did you get for 3A? Or sorry, 4A? Good job. Justin, B. Good. 13D plus 3 or 3 plus 13D. Order does not matter. Annalise. Okay, should be plus 3. After you distribute, we get negative 15 plus 10D. Drop down your plus 3D, your plus 18. So here's how you get positive 3. Negative 15 plus 18 is positive 3. Okay? Sean? Nope. Nope. For now, no. Annalise? Yeah, because it doesn't have a like term, so don't write it. Matt? Yep, you're good. Order doesn't matter. We good? Anyone else? Yeah, that's what he said. Okay, let's go to definitions, and then I want to go to the last part of your warm-up. So in the page 11 where it says equation, let's start with that. An equation, biggest example and difference between an equation and an expression is that this one has an equal sign either between two expressions or between an expression and a constant. It's a mathematical sentence formed by placing an equal sign between two expressions. So it's a mathematical sentence formed by placing an equal sign between two expressions. Right here. So write something like that down. And if you want to jot down the example, one example of an equation is 2x minus 1 equals 6x plus 5. So again, an equation has an equal sign, an expression does not. Does anyone have experience or know how to solve an equation? Adam, go ahead. Go ahead. Okay. Yeah, that's what we're going to do today. Yeah, good job. Charles? Very good. Yep. Well, hold on, that's not right though. If you move 5 to this side, you have to subtract it. And just hold that thought, because I'm going to get to that. Just give me like 5 minutes. Okay, Doug, hold on. Hold on. I'm going to get to it. Okay, second definition, then we'll get to it. You guys are a little bit ahead of me. So solution of an equation. So second definition. The solution of an equation is kind of what Charles and Doug were just discussing. It's a number that produces a true statement when it is substituted for a variable. So when we solve an equation for x, you're going to have x on one side, you're going to have a number on the other side. We're solving an equation for a variable. Doesn't have to be x, it could be any variable. The point of an equation is so that you can figure out the answer. You're first setting it up based on a problem. We will do a lot of word problems at the end of this chapter, translating a word problem to an equation and then solving. You need to solve for x, which produces a true statement when you substitute it for the variable. Adam? Oh, you mean if I was moving the -1 to this side, you would add it. And I'm getting to it. Charles? Hold on, hold that thought, okay? Okay, Doug, hold that thought. One more definition, solving an equation, okay? I'm going to cross this part out. Don't write the second part, I'm going to read it though. All I need you guys and girls to write down is the first part. So solving an equation is finding all solutions of an equation. Solving an equation is finding all solutions for an equation. There are some times where you can have no solution or many solutions when you're solving an equation, which we'll get to later on. The second part of this that your book said is you could also use mental math to solve a simple equation by thinking of the equation as a question. We're going to do this a little bit, but I'm not a big fan of this because since you guys are 2 years accelerated, you're not going to see many simple equations. They're going to be more difficult. They're going to have more steps. So I will still show you what they mean by solving it by asking a question, okay? But more so we'll see the ones that you have to combine like terms first and then move things, okay? All right, so here was the second part of your warm-up. Okay, example 1, letter A. I wanted to see if you guys could do these. Zach, what did you get for example 1A? Good. X plus 6 equals 9. In the sentence in letter A, what word means equals? In the sentence in letter A, Alyssa, what word means equals? Good. The word is means equals. The word sum means add, and this word and tells you what to add. So I'll say that again. Sum means add. The word and means the two terms that you're adding together. The word is means equals. So if you didn't already know that, or if you didn't get that, that's how you translate a verbal sentence to an equation. And again, that was part of your warm-up because you guys have done this before. Charles? Oh, okay. Charles, letter B. Good. 12 minus y equals 15. Same setup. Is means equals. In this case, of course, you guys know the difference means equals. Difference means subtraction. Sorry, I don't know why I just said that. Difference means subtraction. The word and here tells you the two terms that you're subtracting. My brain must be a little goofy today because it's Friday. Sorry. Difference means subtraction. You're subtracting these two terms. Sean? How do I? Okay, can you explain that again? We're not there yet. All I want you guys to do for now is translate them. You're ahead of me. I'm getting to that. Jeremy? Okay, you're ahead of me. You're ahead of me. No, you're ahead of me. Yes, it's still subtraction. Okay, so let me just say this because two of you guys are asking. So to make this into a question, you would ask yourself, 12 minus what gives us 15? So Jeremy just basically told us the answer. 12 minus negative 3 gives us 15 because 12 minus a negative 3 is really 12 plus 3, which is 15. Okay? So the answer to this would be negative 3 if you were solving. But turning it into a question, kind of like Jeremy did and Sean was asking, that's how you would get negative 3. We're going to do that, though, without turning it into a question. Justin? Yes, but not always. That's not always going to work. But on this one, it does because it's a very, very basic equation. Doug? If it's a one-step equation, yes. Sean? Yeah. You should really do 15 minus 12 to get your answer, but hold on because I'm getting to that. Okay, I want to make sure you guys are doing the right process. You're just ahead of me. Okay, letter C. Briar, what'd you have for letter C? Equals? Good job. So negative 4p or negative 4 times p equals 32. And then H, what did you get for the last one? Good. N divided by 2 equals 9. You may also have N divided by 2 written this way equals 9. Donatus. You okay? You're raising your hand. Okay, so letter C, product means multiplication. Letter D, quotient means division. Emma, you with us, right? Okay. Questions on the warm-up and definitions. All right, flip over. Okay, example 2. We need to tell whether 9 or 7 is a solution of x minus 5 equals 2. So the very first thing I want you guys to do is rewrite the equation for both of them. X minus 5 equals 2. And I want to teach you something kind of different here as we talk about this. So still an introduction to equations, bless you. We need to decide whether 9 or 7 is a solution of that equation. So let's plug in 9. So is 9 minus 5 2? No, I hope you guys are saying no. Anyone know what we can do to the equal sign to indicate that it's not a solution? This is something I'm not sure if you know or not. Briar, do you know? Yeah, but there's a way, there's notation for that. You're exactly right. Matt? Yep. You guys ever seen that? Not equal to? Okay. Hey, it's true. So you'll also see it going the other way. You'll see it going either way. 9 minus 5 is not equal to 2, right? Of course, 4 does not equal 2, at least in our generation or our world right now, right? All right, letter B. Let's plug in 7. This is also really hard. Adam, is 7 minus 5 2? Okay, do we all think? Do we think? This might be the hardest thing this year. Okay, so don't put a line through it because 2 equals 2. I'm sure. I'm sure. So yes, yep, that's a solution. Okay, so you're going to go home and be like, man, we haven't learned anything new in math. All we learned was 2 equals 2. Correct. Correct. All right, so let's go to example 3. All right, so here we need to solve them using mental math. So I'm going to show you how to do it without mental math. So can someone raise their hand and tell us? I'm going to turn these into a question. What plus 3 equals 11? Alyssa? Good, 8. Who can turn letter B into a question for us? Briar? Good job. Who can answer Briar's question? Annalise? Good. Who can make letter C into a question? Emma H? Good job. Who can answer Emma H's question, Sean? Good job. Who can make letter D into a question? Charles? Good job. That works. Who can make that into another question? Because I don't know if everyone knows how you got that. Very good. Adam? Very good. Who can answer either one of their questions because it's the same answer? Jeremy? Good job. All right, so too easy, right? Doug, do you have a question? But we're not doing that right now. All we're doing right now is turning it into a question. That's all we're doing, okay? Charles? Go ahead. Wait, for letter D? Well, you're right, but you want to turn this into a question. I know, but you need to keep all those terms there, is what they want us to do. Okay, let's do just number 2 of the closing. Does anyone feel like reading that for us? Annalise? Well, we're skipping this lesson, going to the next one. Number 2. That's too easy. Okay. Good job. Okay. First thing we need is an equation. Who can help us set up an equation to solve here? So set up the equation, which means you need to have a variable on it. Justin? Okay, that works. What's another equation we could use? Anyone have another one? Charles? Good. This is typically how I would do it, is this way. But that's because I've solved equations for a long time. They both mean the same thing. Okay? Regardless of which way you use to solve it, what is X? How many people, what was the question, rode go-karts that day? Briar. Good job. So the X is equal to 200 people, I'm going to abbreviate, rode go-karts that day. Charles? Oh, yeah, I said. Yep, sorry. It should be 200 times people rode go-karts. Thanks, Charles. My fault, guys. Why are you confused? Oh, okay. You sure? Okay. Just making sure. All right, Doug. Yep. 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 Okay, so this lesson was an intro to 2.5, even though we just did a closing. So flip over to lesson 2.5. All right, here's the fun stuff. Okay, we are going to solve equations using addition and subtraction. So we're on lesson 2.5. We're going to skip the warm-up. We're going to go right down to inverse operations. Who can remind us what the word inverse means? What does inverse mean? Matt? The opposites. So here's where we're going to start. Inverse operations are two operations that either cancel or undo each other, such as addition and subtraction. Inverse operations. Two operations that cancel or undo each other, such as addition and subtraction. Kind of like -2 plus 2 is 0. 5 plus -5 is 0. -3 plus 3 is 0. Too easy. Those are inverse operations. They're operations that undo each other. Charles? Yeah, you could think of it like that, and I'm going to show you on some examples. Doug? Yeah. Yep. Annalise? Yep. Yep. If it's the same. Yep. Okay. So this is also really difficult, and I'm being sarcastic. Would you ever have a guess that equivalent equations have the same solution? They're the same thing. They're equal. They're equivalent. So they're going to have the same solution. I'm not sure why your book gives us all these definitions, but we need to go over them. Equivalent equations are equations that have the same solution. Charles? Wait, is it equal to what? I didn't hear the last part of your question. No, they do not. Okay. Yes, they're equivalent. It's a very simple, basic one. But yeah, you could say that. They're equivalent. Yep. But it's a very basic. No, they do not have to be related. And now you'll see that today. Okay, so let's take a look at the subtraction PO first. I call this, here's what, I call this subtraction PO, kind of like the Teletubbies, because property of equality, you'll see in geometry when you guys write proofs. Property of equality you may abbreviate as PO, P-O-E. So I think PO was the yellow one.
No, that wasn't a yellow one.
Which one?
Wait, was he red?
Or was that Lala?
Yeah, he was on my sister.
PO was red. Okay. When I used to babysit in high school. Yeah. All right, so here's what this is. Subtraction property of equality. When you subtract the same number from each side of an equation, it produces an equivalent equation. When you subtract the same number from each side of an equation, it produces an equivalent equation. So write something like that in the box that you guys are all looking at right now, if you're not already writing. So what does that all mean? Here's what this means. We're just going to do one example. So if we have something like x plus 3 equals 5, we're going to use the subtraction property to produce an equivalent equation. As of now, both sides of this equation are equal because obviously there's an equal sign right here telling us they're equivalent. They're equivalent expressions, but it's really an equivalent equation. All you do here to use the subtraction PO, in other words, the inverse operation, this undoes or cancels the 3. So we use subtraction PO to get x on the left-hand side. 5 minus 3 is 2. So you would ask yourself, well, did that work? Is 2 plus 3 5? Yes. Subtraction property of equality says if you subtract something on one side of the equation, you must also subtract it on the other. It produces an equivalent equation. You also need to remember when you're solving an equation, think of a scale. the middle of it's the pendulum. If you do something to one side of the scale, such as add a weight to it, it's going to go down because it's getting heavier. If you do that to one side of the scale, you also need to do it to the other. It has to be equal. What you do to one side of an equation, you have to do on the other. You also could think of it as you have to be fair. What you do to one side, you have to do to the other side. Every single time. Annalise?
I have two questions. One is it always
No. No.
only if it's adding?
You'll see. We're going to do examples.
And also, how do you figure out what numbers?
I'm getting to that. This is just a very brief intro. I'm getting to it. Sean? This is just a definition. Hold on. Adam?
So you said that we're trying to figure out the which is what I thought
What equation did I give you before? Which one? Oh, okay, hold on. I'll go back to that. Okay. You should be able to go back to it on your own, actually. All right, so let's look at example 1 because all of you guys that just said to me, I don't understand what you did. Here's where we're going to go through the process. So the directions for these are very, very basic. We're going to solve the equations using subtraction, so they tell us what to do. Okay, before you start doing it, listen. The very first thing you need to realize is x needs to be on the left-hand side of the equation. On the right-hand side of the equation, in case you don't know your rights and lefts, you need to always have all the constants or all the numbers. Doug, keep your hand down for a couple minutes, okay? Let me go through some examples. On the left needs to be x. On the right needs to be all the numbers. To get x by itself in letter A, we need to get 9 to the other side. How do we undo this 9? In other words, how do we get this 9 to move to the other side? Raise your hand if you think you know. How do we get this 9 to move to the other side? Sean, what do you think? Yep, minus 9, minus 9. What you do to one side of an equation, you do to another. The only way to get 9 out of the left-hand side is to subtract it because 9 minus 9 is 0. Goes away, it's gone. You're left with x all by itself on the left-hand side. So then you say to yourself, this is why you need to know your integer rules really well. Negative 3 minus 9 is negative 12. That's the answer. To check your answer, you could ask yourself, is negative 12 plus 9 negative 3? Yep. So your goal is to get x all by itself on the left-hand side and get all the numbers on the right. Hold on one second, Annalise. So when you get negative 12, you can check it by plugging it back in or asking yourself that question. Is negative 12 plus 9 equivalent to negative 3? Yep. That's why that uses the subtraction property of equality. Briar? Okay, good. Yep. So on letter B, our goal is still to get x on the left-hand side. So you're asking yourself, to get x all by itself on the left, how do you get positive 5 out of there? In other words, how do we move positive 5 to the right? Alyssa? Yeah, so we need to subtract 5 on both sides to get it to the right. The reason you're subtracting is the opposite or inverse of positive 5 is negative 5. 5 minus 5 is 0. X is all by itself on the left. Emma M, what's negative 2 minus 5? Good. So you get x is negative 7. Take it back to the original problem. Is negative 7 plus 5, Zach, negative 2? Is negative 7 plus 5 negative 2? Yep, so you know that's right. You with me? Annalise, you still have a question? Okay. Yep. Yep. Emma M?
So we're using the inverse operations.
Yes. All right, letter C. Do you know, I hope you didn't do this one yet. What's wrong with letter C? Or in other words, what's different with letter C than A and B? Briar, what's different? Yes. Very first thing you need to do is take m plus 15, write it on the left. Take 62, write it on the right, put your equal sign in the middle. Rewrite it. Your variable always needs to be on the left. You're not going to solve for something and tell me 2 equals m. You need to say what the variable equals. Okay, so you need to first rewrite it. So it's m plus 15 equals 62. So rewrite it to the variables on the left. Now we're going to solve. So we need to get m all by itself. Justin, how can we get rid of the 15? Okay, but adding a negative is the same thing as subtracting. So I want you guys to put minus 15 underneath. Make sure you're showing your work. You are always doing the inverse operation. The opposite of addition is subtraction. 15 minus 15 is 0. You're left on the left with m. Emma H, what's 62 minus 15? Good. Who can tell us how we can check our answer? Matt, how can we check our answer? Good job. Go back to the problem where we wrote the variable on the left-hand side and ask yourself, is 47 plus 15 62? Yes. Okay, can I give you a harder one? Okay, is everyone clear so far? This is very important in algebra. Oh, wait, not that. Hold on. Okay, letter D. Add it wherever you have room. Okay, 10 equals x minus negative 2 plus 6. We're getting too bored with those easy ones. We need to try a hard one. Okay, 10 equals x minus negative 2 plus 6. What is the very first thing we need to do? It's the very first thing we need to do. Emma M? Yeah, rewrite it to the variables on the left. So I'm going to rewrite it as x minus negative 2 plus 6 equals 10. So rewrite it to the variables on the left. All right, all of you smart people out there, now what can we do? Sean, now what can we do? Sure? I think you might know, you just don't want to say it. Sure? Nope, nope. You got to do something before that. Adam, go ahead. Wait, go ahead, Adam. Nope. Sean, what were you going to say? And make it a. Good. Okay. See this? Back to beginning of chapter 2, end of chapter 1. Two negatives back to back makes a plus. Okay. Very first thing you need to do is change this to be x plus 2 plus 6 equals 10. Do not move anything until you simplify each side of the equation as much as you can. All right, so now what can we do before we move anything? Doug, what do you think? Alyssa? Good job. Once you get all the x's on the left-hand side, step 2, combine like terms. You see why we learned this before equations? Combine like terms. X plus 8 equals 10. It now looks like the previous 3 problems we just did. Give me a head nod. You with me? Okay. Doug, now what do we need to do? Good. So now we need to get x all by itself on the left. Minus 8, minus 8. Donatus, what is x? Good. To check your answer, I would go back to this step right here. Actually, or even this step, it doesn't matter. And double check and make sure 2 plus 2 plus 6 is 10. Or 2 plus 8 is 10. And it is. Adam? Yeah. We're getting to that next on Monday or Tuesday. We're getting to that. This is the basics. Today is just addition and subtraction, which I think is easier than multiplication and division for you guys. Okay, let's talk about ADPO, and then I'll give you guys your homework. So addition PO, just like subtraction. So flip over. Addition PO says adding the same number from each side of an equation produces an equivalent equation. adding the same number from each side of an equation produces an equivalent equation. So it will be. You know what I mean? Okay. So just like we did before, when you're solving for x on equation, what you do to one side, you have to do to the other side. You have to be fair. It has to be equal. It has to be equivalent. Okay? And again, the example I have up there is the easiest and most basic equation that you are going to see. Just like on the, besides the last example I gave you. Next week sometime you guys are going to come in, you're going to have a warm-up as long as the length of the smartboard, and you're going to have to solve for x. So pretty soon they'll get to be really long. It'll be fine. Yep. But x will be on both sides in chapter 3, Charles. In chapter 2, x is always just on one side. I agree. Can we just get to the hard stuff? I agree. You guys okay with that? We'll just throw in all the hard stuff now? Yeah, I know. Okay, so what do you think I'm going to write underneath here? 2 years ago, I had the sixth grade class would always try to guess what the definition, what example we were using. Adam, what do you think? On one side or both sides? Good job. So here's what we need to do. To show it's the addition property of equality, what you do to one side, you do to the other. Add 3 to both sides. Annalise, what's the answer? Good job. X is 8. To check your answer, ask yourself, is 8 minus 3 5? Yep. What? Adam, don't confuse me like that on a Friday. Charles? Yep. You're ahead of me. That's Monday or Tuesday's lesson, but yes. So basically, as what Charles was summarizing and reiterating for us is, whatever you do on both sides, that's the property that you're using. Since we're adding 3 on both sides, the justification for a geometry proof would be ADPO, addition property of equality, because to get from this step to the next, you added 3 on both sides. Annalise? It's a subtraction sign, which is the same thing as a negative. I'm always going to say that. Nope. Adam? Right. Correct. Yep. Zach? Yep. All right, let's do some basic examples. Okay, on letter A, what's the very first thing we need to do before we solve Emma M? Good. First thing you need to do is rewrite it. So it's y minus 11 equals 23. Step 1 on letter A, rewrite it so the variable's on the left. If you didn't do that, Donatus, whatever you're doing, stop. Stay with me. Variable should be on the left. Okay, now we need to solve. So using ADPO, Doug, how do we get the 11 to the other side? Good. So we're adding 11 to both sides to get y by itself. Alyssa, what is y? Good job. Y is 34. Okay, letter B. I'm going to speed it up a little bit. Annalise, what do we do? Good. To get rid of the negative 5, we're adding 5 to both sides. Remember, x is always on the left. Numbers are always on the right. We're solving. Charles, what is x? Good. X is 37. Letter C. Breyer, what do we need to do first on this one? Good. Notice on C that the number comes before the variable on the left-hand side. That doesn't bother us. It's the same thing. The variable's still on the left. We don't care. We don't care that the number's in front. Still the same process. Negative 2 plus 2 is 0. They cancel each other. We end up with W equals 10. So you could check by saying, is negative 2 plus 10 8? Yep. Charles? You'll see eventually. Basically, when you get to geometry proofs, it matters. And in algebra, you have to say, well, guys, I'm not done, so don't put your notes away. You have to say what x equals or y equals. Yeah. There's a property called symmetric property of equality in geometry you'll use that you have to justify your step as to why you're flipping it. So the reason I'm so stuck on this is you can't just flip it. You have to explain why you're flipping it. So that's why I like on the first step for you to write all your variables on the left, numbers on the right, if you're able to. Okay? Yeah, there's a much higher reason for that I'm having you guys do this. So I promise anything that I'm having you do, there's a reason for it. Okay? Annalise? Well, it'll be as easy as this one. Okay, add one more example. Dun, dun, dun. All right, x minus 4 minus 2 equals 10 minus 2. Nah, it's not. These are easy. We're going to come back to them in a week or two, and you're going to say, man, that was easy. Sean, what do you think we need to do first?
Subtract -4 minus 2.
Good. Okay, so on the left-hand side, combine like terms. What can we do on the right-hand side? Alyssa? Good. Combine like terms on both sides. What does your second step look like? So combine like terms on both sides and make me think. Donatus, what does the equation look like on the next step? Equals what? Okay, try to sound a little more excited. I'm excited. You should be excited. Okay, so excuse me. -4 minus 2, sorry. -4 minus 2 is it the same thing as -4 plus 2? I'm choking. So you get -6. It's -6. It's plus a negative or minus, not minus minus. You know what I mean? Go ahead, go ahead.
Wait, if it's minus a negative, it would be x minus -6.
No. Okay, drop down the x. Ready? See what I circled? -4 minus 2 is -6. Whatever the result of this is goes after x. Okay? All right, so Adam, what's the next step?
Plus 6 on the side.
Zach, what's the answer? Good job. So that's as hard as your homework will get. Okay, I need to assign homework. Charles, is this a question related to this? Okay, go ahead. Shh. Yes. Until I know that you all know what you're doing, yes. Okay, homework. Shh. Open up your homework packet to 2.4 first. You have 2 assignments. Okay, on 2.4, I just want you to do 1 to 12. Everyone look at 2.4 quickly though so I can explain it. Look at number 5 through 8. Is everyone looking at 5? Donatus, you with me? 2.4, 5 through 8. Do you see where it says tell whether the given value is a solution or not? So here's what you do. Number 5, you would plug in, do you see the -52? You plug that in for V, and you ask yourself, is -52 divided by -4 equal to 13? Would that one be a yes or a no? Justin? Yeah, it would be yes. So for number 5, you would put yes. I'm just clarifying directions. Everyone give me a head nod. Are you listening, and does that make sense? Okay, number 6. Let's do another one together. Hold on. If you plug -3 in for Z, is -36 times -3 positive 108? Charles? Yep, so you put yes. Okay. And second assignment is practice 2.5. This is the fun stuff. You're into all. So numbers 1 to 28. It won't take long, okay? It's one-step equations. Here's what I need you to make sure you do. Show your work. I'm saying that so slowly so you guys are all listening. Make sure all the variables are on the left-hand side first, and then show your work. Circling your answer would help. When it says check your solution, you may do that mentally. You do not need to write down the whole check your solution part. Show me your work of solving. 19 through 24, guys, on the back. You have to combine like terms first and then solve. So that I don't get a lot of questions on Monday. You guys okay with what to do? Okay. There's a word problem and there's some perimeter problems again, just so you don't forget how to do perimeter. Okay, go ahead and get packed up. If you have any questions, come see me now. Sean? Oh, there are standards for math that by the time you're